I'm back and let's start with exercise 1.3 in the first lesson. So here you have guys, here you have terminating and non-terminating decimals. Coming back to here, write the following rational numbers in their decimal form and also state which are terminating and which are non-terminating decimals. Okay, so guys, let's learn what are terminating and what are non-terminating decimals and what mean terminating decimal and what is non-terminating decimal. Where terminating decimal means the decimal which is having an end digit. Okay, terminating decimal. Terminating decimal means where this decimal will be having an end digit. Okay, we will be having an end digit. Or like examples are like 0.2 or 0.36 or 3.365. So all these are terminating decimals, guys. Okay, where you will be having a decimal point, right? So that's what we have said. Decimal point, okay, decimals, where it will be having a finite number of digits are there. But coming back to the non-terminating decimal, where the decimals which are where they does not have any ended digit. Okay, for example, I will show you like 0.181818. It goes on like that. Okay, it won't have or it does not have any ended digit. Okay, now for non-terminating decimals, there won't be any end digit, means the digit goes on. Okay, it will be having infinite digits are there. Okay, infinite number of digits are there. Infinite number of terms also we can say. For example, 0.333 or 0.63 bar. Okay, well, we can't keep on writing 3, right? So then what would we do? We can also write this 0.3333 as 0.3 bar. Okay, well, this bar shows the infinite digits. Okay, the bar shows how many digits it goes on. Okay, so this is what a terminating and non-terminating decimal is. Okay, so this will be having an end digit. So here there won't be any end digit. Okay, where the digits goes on. Okay, the digits further goes on in non-terminating decimal, guys. But terminating decimal is having an end digit where finite digits are there. Here we will be getting an infinite digit. But coming back to the our question, so first one, here they have given few fractions like 3 by 8, 25 by 5, something like that, and they asked what? They asked to state which are whether they are terminating or non-terminating decimal. Okay, so now what do we do? First one, the given first one is 3 by 8. So to show either this is terminating or non-terminating, firstly, we must do division. Okay, well, by doing division, we will be getting right. So by doing division, what happens? Let us start this process firstly. Okay, well, doing it, we will getting it. So guys, here you have 3 by 8. Now let us try to divide it. Well, here guys, 8 becomes divisor, right? 8 becomes divisor and 3 becomes dividend. Clear? Now what we do? Try to divide it. So here guys, where divisor is greater than dividend, therefore division won't happen. Okay, we can't do any division. Where divisor means 8, right? So where divisor, this is divisor, this is dividend. V and D. Okay, dividend. You remember like that. Okay, divisor and dividend. Now what happens? Dividend. Okay. Sorry. Okay, now here where divisor is greater than dividend, right? So therefore division won't happen. Okay, then what you do? You try to take decimal point, keep 0, make a point, and you can, while doing this, okay, while making a 0 after number, if you place decimal point after a number, then we will be getting a right to mark 0 in the dividend place. Okay, we will be getting a right, something like civil right. Well, so therefore we will be getting a right to mark 0 in the dividend place after that given number. So now what happens here? But now dividend is greater than divisor. So then what you do? Just try to go with division form. Okay, 8 table 8 4 is 38, 3 is 24. So what you do? You mark 24 over here. Okay. Now again, 30 minus 20 minus 4, this gives 6. Now what you do after decimal point? After decimal point, right? Again, where dividend is smaller than divisor. So what you do? You again keep no zeros are required. You can make 0 as it is, because after decimal point, right, we are marking all the numbers. So 0 is enough. Now what you do? 8 table again. 8 7 is 56. 8 8 is 64. 7s are 56. 7s are 56. Now you take 7. So you make 56 over here. You got like 40. 8 5s are 40. I got it. 40. So 40. Clear? So therefore 40. Therefore we got 0. Where 0 is the remainder. Where coefficient is what? 0.375. This is the coefficient and 0 is the remainder. Now what you do? Would you say that like this is a terminating or non-terminating decimal? Which of the decimal is it? Is it a terminating or non-terminating? Yes, it's a terminating decimal because you got 0.375, right? So 0.375, it's a terminating decimal. Means 0.375, right? We are having a finite digits are there, okay, where this decimal has come to an end, like 5 is the last digit, so this decimal has come to an end. Is it clear? Sorry. This decimal has come to an end. Now therefore this is a terminating decimal. Let me write on it, terminating decimal. Or guys, when we are coming back like here, according to the theorem we have where 2m into 5n, where if you are getting like without doing this division, okay, without doing this division process, you can state whether this is you can state whether this is a terminating or non-terminating without doing division process. You can make like, because here where if the denominator, so this is the denominator, right? If the denominator is in the form of 2m into 5n, or if the denominator is in the form of 2m or 5n, okay, 5n, sorry. Let me again say, if the denominator is in the form of 2m into 5n or 2m or 5n, if the denominator is in the form of these three forms, then it definitely would become a terminating decimal. It definitely would become a terminating decimal. If the denominator is not in the form of this, or if the denominator is in the form of like 7 power m, 8 power n, 5, like 5 power 6, something like this, then it definitely would become a non-terminating decimal. Are you getting it? Now for example, here we have got this as a terminating decimal. So to prove this, what would I do? I will be taking 8 again. Now let us do LCM. Let us do LCM process. We all know where 2 4, sorry, my writing has become doctorate writing nowadays. So here you have where, okay, 2 8, where 2 4s are 8, again 2 2s are 4, 2 1s are 2. So this becomes what? Where 8 equal to 2 cube, right? So 2 cube means it's in the form of 2 power m, where m is an integer. M is an integer, right? M is something like an integer. M is an integer. So where it's a positive integer. M is a positive integer. Now here 2 power 3 means 2 power m, where this is in the form of 2 power m. So therefore it's a terminating decimal. Are you getting it? So guys, if you wanted to know the answer like 0.3756, something like that, then we must definitely perform this division process. But whether if you wanted to find either this is a terminating or non-terminating decimal, you can go with this process. Clear? Are you getting it? Now at present in textbook they have given something like division process. So now let's go with the division process. Okay. Now the second question. Second question is 229. 229 divided by 200. See, 400. Okay. So this is the second question, guys. Where 229 divided by 400. Okay. Okay. Now here 229 divided by 400. Now, okay. The divided, where if the denominator is in the form of 2 power m into 5 power n, then it definitely would be a terminating decimal. If it's not in the form of 2 power m into 5 power n, then it will be a non-terminating decimal. Firstly, let us go with this, okay? Let us check whether this is a terminating or non-terminating decimal. Then let's go for the division process. Are you getting it? Now let's go for 400, where 400, if I go for LCM in for 400, 2 times, right? 2 over here, 200, 2 2's 4, right? So 200, 200 times. Again here, 2 over here, 50 times. 2 5s are 10, 0 as it is. Again, no, 5 10. 5 1s are 5. Here you have like 5 1s are 5 10s are 50, right? Sorry. 5 10s are 50. Again, 2 5s are 10. 5 1s are 5. So guys, what we have at 2 1 2 3 4. So we got 2 power 4 into 2 power 4 into 5 power 2. Okay, 2 power 4 into 5 power 2, where this is in the form of 2 power m into 5 power n. Is this in the form of 2 power m into 5 power n? Yeah? Yes, very good. So where this is in the form of 2 power m into 5 power n, where 2 power m, let m be 4, like n be 2, right? So here where this is in the form of 2 power 4 into 5 power 2, this is in the form of 2 power m into 5 power n. So therefore, what would I say? Therefore, this is a terminating decimal. This is a terminating decimal. I will show you. You will not know what you do. You make the division process, okay? Division process, like 400, where 400 becomes divisor, right? 400 becomes divisor and 229 becomes dividend. Now you go with it. Now here you have where 400 means 0 point. So because here dividend, so divisor is greater than dividend. This is SAR, divisor or SAR, divisor. Let me go for SAR, okay? SAR, divisor. I will be getting confused with divisor and dividend. I don't know whether what is divisor and dividend. Okay, let it be. So here you have divisor, this is dividend, right? So then what you do? You go with 0.0 because I need the big value or largest value, right? So 0 point over here, I have 229, 2290. Go for 5, okay? 4 5s are 20, 4 5s are 20, right? So 22, 400 into 5. Okay, 2000. 400 into 2000. So we got 2000, right? Now what you do? You go for okay, minus 2000, 290 minus 2000. This becomes what? 290. Add again a 0. Add a 0 over here. Now you go for 4 7s are 28. 7s are 28. Okay, you go like this. Now here you will be having 100, where 900 minus 800, this gives 100. So you go for 100 again. Now you make again 1000 over here. This becomes what? For 2s are 8, right? For 2s are 8. Okay, let it be. For 2s are 8 means 800, right? 800 we got. And now here 1000 minus 800, this gives 200. 200. Is this clear? Is about clear? 200. Now go with again which 400 means 1000. You go for 5 again. Okay, for 5 is 20, like 400 into 5, 2000. So 2000 I got. And the denominator where the remainder will be 0. And the remainder is 0. Okay? Is it clear? Where here? Okay, let it be. So here you have where 2290 minus 2000. So here you got this, where this is the terminating decimal, where 0.5725. Okay, we got a decimal point where 0.5725, where this is a terminating decimal, where it has an end digit and it's a finite decimal. Clear? Where this is it is having an end digit, so therefore this is a terminating decimal. Terminating decimal. Terminating decimal. Clear? Clear? Now let me go for the next one. Third one, 4 1 by 4 1 by 4 1 by Now what happens guys here, 4 1 by 5, coming back to here, where this is in the form of mixed fraction, right? Now what you do, it's in the form of mixed fraction. Now make it a proper fraction like that, where here 4 into 5 plus 1, we know that 4 into 5 plus 1, 4 5 is 20, 20 plus 1 21, so therefore we got what, 21 by 5. Okay, clear till here? 21 by 5. Now 5 becomes what? SAR. 5 becomes divisor and 21 becomes dividend. Now what you go? You go for 5. Okay, 5 by 21. No need to make any decimal points. No need to make, because here where 5 is lesser than this dividend, where dividend is greater than divisor, right? So no need to add. Now what you do? You go for 5 4s are 20. 5 4s are 20. So here let me go for 20. 20 over here. Here 1. Okay. Okay, let it be. Now you make a point. You make a point. You take a decimal point, because here you got 1. 1 is the lesser value, so I have taken a decimal point. Now you place what? After making a point, you can add how many zeros you want. Okay, not more than 1 0, but you make a 0. Add a 0 over here. Okay, 5 2s are 10, right? 5 2s are 10. So 10 minus 10, this becomes 0. So therefore I got what? 4 1 by 5. Therefore this is a terminating decimal. How can I say terminating decimal? To prove this, what do I do? Terminating decimal. As I said, terminating decimal should be in the form of 2 power m into 5 power n, or 2 power m or 5 power n, right? 5 power n. So here you have the decimal, but denominator should take this value, okay? If the denominator is in these values, like 2 power m into 5 power n, only denominator, remember, not numerator. This game is only with the denominator, okay? We must only consider denominator. No need to consider numerators, okay? Now here the denominator is in the form of 5 power n, then it is also a terminating decimal. So here you have 5, where 5 is nothing but 5 power 1, where this is a terminating decimal, right? 5 power 1 in the one place you have n, right? 5 power n or 5 power 1. Instead of n, we have placed 1, right? So then it definitely would become a terminating decimal. Therefore we got 4.2. 4.2 is having an end digit. It is having a finite digit. Therefore it's a terminating decimal. Alright? Alright? Now let me go for the next one. Fourth one, 2 by 11. Sorry. 2 by 11. Let us see whether this is a terminating or non-terminating decimal. 2 by 11. Coming back to here. 1 by 4. 2 by 11. Now, you first guys look after this denominator. Now let us make, where 11 is a prime number, then what would happen here? If we go for the LCM process, we will get 11 1s 11, that's alright. We will be getting 11, only 11. Okay, let's perform division and let's understand later. Now here, where 11 becomes divisor, okay, where 11 becomes SAR and 2 becomes dividend. End, okay, dividend, end, SAR, end. Okay, let it be. So 11 becomes a divisor and 2 becomes dividend. Clear? Now what you do? Where 2 is lesser, where here divisor is greater than the dividend. Now what you do? You mark a 0 and a decimal point over here. And a decimal point over here. Add a 0 over here. Now this becomes what guys? 7 1s are 11. 1s are 11. This becomes 8. So again 0. I need 0 over here. Sorry. Not 8. 9. Okay. Okay, sorry guys. So here you have, where 11 1s are 11 and here you have 9. I have made a 0 over here. This becomes what again? 11 8s are 88. 11 8s are 88. Again, how much? 90 minus 88. This becomes 2, 0, 1, 11 by 90, 0, 8. This becomes 8, 88. And here this goes on. Okay, the process which is there, it goes on. Is it clear? The process which is there, it goes on, okay? Like 1 8 1 8 will be like that, okay? So therefore the answer would be what? The 1 8 1 8 1 8 1 8 1 8 1 8. So the values which are there, guys, these values goes on, okay? is not having an end, or it does not have any end digit. Okay, here it does not have any end digit, so therefore it will be having a infinite digits, infinite digits, or does not have any end digit. Okay, no, or not, it does not have any end digit. So therefore what happens here, I can write this answer as 0.18 bar. Bar means it goes on, right? So therefore I can write it. Now coming back to the other side, where here 11, if I take LCM for 11, then what happens here? 11 ones are 11 itself is the 1, right? So I got 11, where 11 power 1, but it is not in the form of 2 power m or 5 power n or 2 power m or 5 power n, right? It is not taking all those forms, so therefore this will become a non-terminating decimal. Clear? Therefore this will become non-terminating decimal. Alright, now let's go for fifth one. 8. Okay. 8 divided by 125. Okay. Okay, I will try something like 8 divided by fifth one. Now guys, what happens here? 8 divided by 125. Now solution. Now here 8 divided by 125. 8 becomes what? Dividend, where 125 becomes divisor. Okay. Now what you do? You make 0 decimal point over here. Now you add a 0. Okay. Okay. Where after decimal point we will be getting a right to add 0. Clear? Now what you do? You have 0 point after over here. Then you make it. Now then what you do is, again I need 0 because 80 is dividend, right? Where divisor is greater than dividend. Then what you do? You again mark another 0. So here you can place a 0. Okay. Now you go with the table where 125 into 6. 6 1 the 6 is 12. 12 6 5 30 650. This is the one. 12 6 5 30 750. Sorry. Where 6 are 750. Now here I got what? 50. Now after decimal we can mark a 0. Okay, we can add a 0. So that's what I have kept a 0 over here. Okay, so this becomes 50 and I made a 0. Okay, I marked a 0 over here. Then what happens again? Where 25 into 2. No, 25 into 4. 4 ones are 4. 4 is 8. 4 5s are 20. 25 into 4. This gives 500. Okay. Now here where 500 minus 500, this becomes 0. Therefore this is a terminating decimal. Now what you do for to prove whether this is a terminating or non-terminating decimal, what you do? You go for LCM process. Are you getting it? Are you getting it? Now you go for LCM process for 125. Remember, make sure that you must do LCM only for the denominator, not for the numerator. Okay? If the denominator is in the form of 2 power m into 5 power n, or if the denominator is in the form of 2 power m, or if the denominator is in the form of 5 power n, then it definitely would become a terminating decimal. So therefore we have 125. So you go for LCM like 5 table. Okay? Means 5 right after, at last digit I got 5. So then I felt like 5 meant it would. Now here you got 2, here 5, 25. Again 5 5s are 25. 5 1s are 5. Where 125 equal to 5 cube. Well guys, you can see where 125 is equal to 5 cube. Where 5 cube is in the form of 5 power n. Right? 5 cube is in the form of 5 power n. Where this would become a terminating decimal. Therefore we got a terminating decimal 0.064. So therefore I can say this is the terminating decimal. Alright. Done? Yeah, done. So this is the terminating decimal. Clear? Thank you. Hey guys, let's start with the second one. Without performing division, state whether the following rational numbers rational numbers will have a terminating decimal form or a non-terminating decimal. Okay, so guys, here we have without performing any division. Now, actually, in the first question we have performed division and we stated whether those are terminating or non-terminating decimals, right? But now, what you do without performing division, state whether the following rational numbers. So these are the rational numbers. So following rational numbers will have a terminating decimal or a non-terminating decimal. So without performing any division, we must state whether those are terminating or non-terminating. But guys, as you know, where to state whether the given numbers are terminating or non-terminating, what is the main thing that we know? We know the theorem. According to that, where if the denominator is in the form of 2 power m into 5 power m, sorry, yeah, that's all, 2 power m into 5 power n or 2 power m or 5 power n. Clear? If the denominator is in the form of 2 power m into 5 power n, or if it is in the form of 2 power m or 5 power n, then definitely it would come it would become under terminating decimal. Okay, then definitely it would come under terminating decimal. And non-terminating decimal means apart from this, if this is in the not where the denominator is not in the form of 2 power m into 5 power n, then it definitely would become non-terminating decimal. Clear? Now, guys, what would we do is to find, they asked only to find terminating or non-terminating. They didn't ask what is a decimal or what is the decimal value. Okay, they didn't ask about value. They are not talking about values. They are only talking about find whether these are terminating or non-terminating. So for this purpose, what would we do is, you try to find like LCM. Okay, go for LCM process. So here you have 3, 1, 2, 5. Right. So firstly, to find this whether this is terminating or non-terminating, mostly this will be the very easiest process that we know. So here are 3, 1, 2, 5, right? 3, 1, 2, 5. Now what you do? Go for LCM again, like 3, 1, 2, 5. Okay. Take LCM for this. Now the LCM would be firstly go for which table should go? Okay, go for 2 table. Now 2 means here you get 5, right? So then it won't be the one, okay, the correct one. Go for 3 table. Yeah, 3 ones are 3, 3 fours are 12, not 8. Which table should we take? Can we go for 5 table? Okay, let's go for the 5 table, okay. 5 table, if you go with this, where 5 6 are 30, here you have 12, 5 2s are 10, and here you have 5 5s are 25, okay. Now again go for 5 table again, because you have 625, right? Then you go for 5 1s are 5, you're getting 12 over here, means 5 2s are 10, you have 25, means 5 5s are 25, okay. Again you go for 5 table, 5 2s are 10, 5 5s are 25, and 5 table over here, 5 5s are 25. Again 5 1s are 5. Clear? So therefore we got what? 5 1 2 3 4 5. So you got what? 5 power 5, guys. Okay, if you do LCM for this, where 3 1 2 5 equal to 5 power 5. Right? 5 power 5 we got. So where this is in the form of 5 power 5. Where this is in the form of 5 power n, right? Where this is in the form of 5 power n. Okay, this is in the form of, which form is it in? It is in the form of 5 power n, I can say. So therefore, this should become a terminating decimal, right? Because it is in the form of 5 power n, right? So therefore, it definitely would become a terminating decimal. Are you getting it? So this will become a terminating okay, terminating decimal. Clear? Now let me go for the second one. 11 by 12, next one. Sorry, what is this one? Wait a minute, okay, let it be. Board totally gone. Should I use this as a laptop? Okay, let it be. Next one, here 11 by 12. Clear? Second one is what? 11 by 12. Okay, so guys, here 11 by 12 means here where 12 is the denominator place. Now just go for 12. Where if I take like LCM for 12, then what would become? 2s are 6 times, 2 3 times, 3 1 time, right? 3 1s are 3. So therefore this is in the form of Therefore, this is in the form of like, if I take LCM, this becomes what? 2 square into 3, right? By 12 equals to 2 square into 3. Guys, here, if you look over here, 2 square, by 12 equal to 2 square into 3. 2 is 4, 4 3s are 12, right? I'm getting like this. So, 2 square into 3, where 2 square is in the form of 2 power m, right? This is in the form of 2 power m into 3 power n. But here, which number we must get? Which number we must have? Where we should get only 5 number, okay? We should get 5, okay? No 3, where 3 is invalid. If we get 3, then this will become a non-terminating decimal. So therefore 3 is invalid, okay? But this cannot be a terminating decimal, okay? Then it definitely would become a non-terminating decimal. Are you getting it? But this is in the form of 2 power m into 3 power n. So this, where 3, we must not get 3. If I get like 5 over here, then it definitely would become a terminating decimal. But here guys, this is a non-terminating decimal. Therefore, let me conclude this is a non-terminating decimal. Clear? Are you getting it? Let's go for third one. 64 by 445. 455, sorry. 64 by 455. Third one. Okay, let me go. Okay guys, so 64 by 455. Now coming back to here, let's go for the LCM for this process again. LCM, okay, LCM for 455 because 455 is in the denominator place, right? So then what you do, go for 455 LCM, 455. Now you go like 455. Let's go for 5 table, okay? 5 table. 5 nines are 45, 5 ones are 5. 7 table. Okay, 7 ones are 7, 7 threes are 21. Okay, 13 ones are 13. Therefore, I got what? 5, 7, 13 means 5 into 7 into 13 will be the LCM for this given for 55. 455. Okay, so therefore, guys, here 455 equal to 5 into 7 into 13. 5 into 7 into 13. But is this 5 into 7 into 13? Is this in the form of 2 power m into 5 power n? No, it is not in the form of 2 power m into 5 power n. Let us assume here, if 7 and 13, okay, if we won't get 7 and 13, if I get like 5 power something, then it would become a terminating decimal because it's in the form of 5 power n. But here we got what? 5 into 7 into 13, right? 5 into 7 into 13. So therefore this is not in the form of 2 power m into 5 power n. So therefore this would become a non-terminating decimal. So therefore let me conclude this is a non-terminating decimal. Clear? Are you getting it? Non-terminating decimal because it's not in the form of 2 power m into 5 power n. So therefore it's a non-terminating decimal. If it is in the form of 2 power m into 5 power n, it's a terminating decimal. Clear? Okay. Now let me go for the fourth one. 15 by 600. Okay. By 600 guys. Fifth one, see fourth one, fourth, anything. 15 by 600. Now, solution. Okay, so you again look after the denominator, 1600. Right? 1600. Now you go like LCM 1600, LCM for 1600. The main thing is guys to find this either this terminating or non-terminating. You firstly simply or blindly go for the denominator LCM. Okay? Try to do LCM for denominator. Where the denominator is 1600. Now do LCM for this 1600. Is this clear? Now do LCM for this 1600. Now what you do? You go for 2. 2 8s are 16. 2 means 800. I got right. So now again go for 2. 2 4s are 8. 400. Again 2. 2 2s are 4. 200. Okay. 200. Now again go for 2 table as well. Now here 2 100. Again go for 2. When means this becomes 4. 2 5s are 10. 50. Again go for 5. Okay. Now go for 5 times are 50. Again go for which table should I go? I go for 2 table, but 2 5s are 10. Again go for 5. 5 1s are 5. So therefore I got what? I got at last I got 100. I reached 1. Now here what you count? 1, 2, 3, 4, 5, 6. And here I have what? Where 1600 equal to 2 power 6 into 5 power 2. 1600 equal to 2 power 6 into 5 power 2, where this is in the form of 2 power m into 5 power n. Is it correct? Yes. Where this is in the form of 2 power m into 5 power n, where m value can be 6. M value can be 6 and n value will be 2. So where this is in the form of 2 power m into 5 power n, where 2 power 6 into 5 power 2. So this is in the form of 2 power m into 5 power n. So therefore this will become what? This will become a terminating decimal. Okay? Terminating decimal. Clear? Done? Now let me go for the next one. Fifth one. Yeah. 29 by 343. Okay guys, when we are listening about the 343, do we have any cube for 343? Yeah, 7 cube is 343, right? So here coming back to here where 29 by 343 our solution would be. Where solution? Now go for this LCM again, where 343. Sorry. 343. So if you go for LCM, what would happen over here? 3, nothing happens. LCM gets, okay? So where 343, if you take LCM for 343, this becomes 7. Go for the 7 table, where 7 cube is 343, right? 7 into 7 into 7. 7 cube is 343, we know. So here 7 cube will be 343, but you go for like 40 or 4, 9, 49 over here. Okay. 7 was 28. So here you have 28 means 9, 4 over here, like 9 over here. So this becomes 63. So here we got what? 49. Now again go for 7 over here. 7 7s are 49. Again you go for 7 7 1s are 7. So therefore 7 cube equal to 343. 343. 7 cube equal to 343 means 343. So what would I do is where 7 cube, right? It's not in the where this 7 cube is in the form of like 7 power m, or this is in the form of 7 power m. It's not in the form of 2 power m or 5 power n or 2 power m into 5 power n. It's not in the form of this, right? So then what you do? This will become a non-terminating decimal. Therefore this will become what? This will become a non-terminating decimal. Clear guys? This will become a non-terminating decimal. Alright? Let me go for the 6th one. Okay. Okay. The next 6th one is 23 by sorry. It's easy guys, but 23 by 2 cube. 2 cube into 5 square. This is the given question. Where 23 by 2 cube into 5 square. Guys, as you see here, when you are looking after the denominator only, when you look over here, so here you have denominator, right? Where 2 cube into 5 square. So the denominator itself says that this is in the form of 2 power m into 5 power n, right? Let m be 3, n be 2. Let this m and n be any positive integers. So this is in the form of 2 power m into 5 power n, right? Okay. But this shows as you can see here, 2 power 3 into 5 power 2 is in the form of 2 power m into 5 power n, right? So therefore I can say what? Therefore I can say that this is a terminating decimal. Are you getting it? Decimal. So if you wanted to write in examination, you can write like here. The denominator itself shows that where 2 power m into 5 power, but this denominator is in the form of 2 power m into 5 power n. You know, make a note like this. The denominator is in the form of 2 power m into 5 power n, where the denominator over here is 2 power 3 into 5 power 2. So therefore this will become a terminating decimal. Okay, like that. Clear? 129 by 2 square. 129 by 2 square into 5 power 7 into 7 power 5. So 2 square into 5 power 7 into 7 power 5. Now coming back to here, where guys you can see where if I eliminate 7 power 5, if I eliminate 7 power 5, then this would become what? 2 square into 5 power 7. Well, then this is the form of 2 power m into 5 power n, right? So this is the form of 2 power m into 5 power n, right? Okay, if I eliminate this 7 power 5, this is the form of 2 power m into 5 power n. But here they have given what? 7 power 5. So this is in the form of like 2 power m into 5 power n into 7 power I, something like that, okay? So this is in the form of this is not in the form of 2 power m into 5 power n. So therefore what would I say? Here you have the extra one, we got what? 7 power 5. If this would be eliminated, if I eliminate this, then it would definitely become a terminating decimal. But here they have added 7 power 5 also. So then therefore what would happen? Therefore I can say this as a non-terminating decimal. Okay. Terminating decimal. Clear? Very good. Now done with 7th one, 8th one. 8th one. 9 by 15. Next question. 9 by 15. Now what happens guys here when 9 by 15 coming back to here, when 9 by 15 means here this can be written as 9 by 15 can be written as 3 times 3, these are 9, right? And 3 5s are 15. This becomes what? 3 by 5, where 5 is in the form of, so we must consider only denominator, right? So where 5 is in the form of 5 power n, means here you have, if you are not having the power over here, then we can imagine over here 1 as, okay, we can imagine 1 over here. So this becomes 5 power 1, where 5 power 1 is in the form of 2 power n. So therefore this is a terminating decimal. Clear? Clear? Next I'll go for 9th one. 36 by 100 guys. Ninth one. 36 by 100. Guys, if you look over here where 36 by 100, if I take LCM again, what would happen? If I take LCM again, I can say, where if I take LCM again, okay, 100 means here 2 or 5 times, 0 over here, again 2 2s are 4, right? Here you have 1 over here, somewhere over here, 2 5s are 10, right? 2 5s are 10. So again let me go for 5 table now, where 5 5s are 25, 5 1s are 5. This becomes what? Where 100 equal to 2 square into 5 square, right? Where 100 equal to 2 square into 5 square, this is in the form of 2 power m into 5 power n, right? But I got 2 over here, I got 5 over here, power something, power 2, something like that. So then this becomes a terminating decimal. Are you getting it? Terminating decimal. Clear? Now let me go for the next one, the last one in the second question, 10th one, where 77 by 210 guys. Okay, 77 by 210. Now coming back to here. Sorry, 77 by 210. Now coming back to here as solution. Let's go for the LCM, the denominator. Let's start the LCM for denominator. So the denominator is 210. The denominator is 210. Now here you go with you go like this, where 210 means here you have 2 over here, 2 1s are 2, so 2 1s are 2 over here, and I'm taking like 2 digits, right? Now you place 0 over here and 2 5s are 10, right? Are you getting it? So I have placed 0 in the middle because I have taken 2 numbers directly. 1 0 10 I have taken directly, so I kept 0 in the middle. So 2 1s are 2, 0 why not 5? Now you mark 3 over here. Okay, place 3. 3 3s are 9. 3s are 9, you have 15, so 3 5s are 15 again. Now you go for the 5 table, 5 7s are 35, again you go for 7 7 1s are 7. So therefore where 210 equal to 2 into 3 into 5 into 7, where this is not, is in the form of 2 power n into 5 power n. Okay, in any angle if you see where it is not in the form of 2 power into 5 power n, because here you have 3, here you have got 7, so this is not in the form of 2 power n into 5 power m. So therefore what you do, therefore this will become a non-terminating. This will become a non-terminating decimal. Decimal. Clear? Non-terminating decimal. Clear? Oh, hope you understood this terminating and non-terminating decimals. Thank you.